These are our perfect square rules just here. So we use these to factorize our perfect squares. You can of course use the methods that we have been, but it's going to be much quicker if you can just recognize a perfect square. So we're going to start by looking at this form because I have a negative 2y in the middle there. So I'm looking for a minus b so that when I square a, I get y squared. So the square root of y squared is y. And there's going to be a minus in the middle there. When I take the square root of the 1 on the end, I'm going to get 1. And we can check that that's correct because this middle term here should be the product of the first and the last term in brackets doubled. So negative 1 times y gives me negative y times 2 gives me negative 2y. And I just need to remember to square it. Using the same method for number 6, I need something in brackets, all squared. The middle term in this one is positive, which means I'm looking at something of the form a plus b all squared when I factorize. Taking the square root of the first term, 4x squared, will give me 2x. Taking the square root of 9 will give me 3. Double checking that, 2x times 3 gives me positive 6x, and doubling it gives me positive 12x. So I know that's the correct factorization. Slightly harder one here because what I have is a fraction there at the end, but you follow the same process. So I'm going to have something in brackets, all squared. I find the first term by taking the square root of x squared, which gives me x. I find the second term by taking the square root of 1/4, and to do that I take the square root of the top and the square root of the bottom, and I get a half. Because that middle term there is positive, I need a plus in the middle there. I can check by multiplying a half by x, which gives me half x, and doubling that gives me x. So I know that's correct because it gives me that central term. Scrolling down to number 12. This one looks difficult because we've got a third in the middle, but it's really not that hard if you just follow that same process. So perfect square is going to be something in brackets all squared. First term, take the square root of p squared, gives me p. The last term, I need to take the square root of 5, and the square root of 5 is root 5. Because that middle term there is negative, I know I'm going to have a minus in the middle of these brackets. And checking, root 5 times p gives me negative root 5p, and doubling that gives me negative 2 root 5p. Again, number 15 involves fractions. Take the square root of that first term, which gives you x. Because that middle term there is negative, I know I'm going to have a minus in the middle, and now I need to take the square root of the final term. The square root of 1 on 16 is 1 over 4. Checking, negative 1/4 times x gives me negative 1/4 x, and doubling it gives me negative half x. So I know that's my complete factorization there.